Hello and welcome to another tutorial by harlepenguin.com. I'm your host Norm. In today's tutorial, we are going to go through the steps to set up an open shading language shader in Blender. We will be using Blender version 2.79. Due to a bug in the 2.79 version, this is the version that's available as a daily build. So to start off with, first we are going to change to Cycles Render, and we are going to select Open Shading Language. It is very important that you select this box because if you do not select it, you will end up with some strange results in your renders. It's also important to note that Open Shading Language only works with CPU right now. If you're interested in learning more about what Open Shading Language is and why it works on CPU as opposed to GPU, take a look at our blog on harlepenguin.com. First, we are going to delete the default cube and replace it with a UV sphere. We will scale this up, set the shading to smooth, take a look in our camera, maybe a little bit bigger. We will also move our camera down. Focus on this. All right, so now we are going to split the screen and we will further split this. And in the top, we will show the node editor, and in the bottom we will look at the text editor. Selecting our sphere, let's add a new material, and down here let's add a new script. So for this script, we are going to name this script internal.osl, and here we will type the basic aspect of the shader. So volume internal float radius equals 1.0, float seed equals 10.0, float f amount equals 1.0, color input color equals 1, output closure color BSDF equals absorption and brackets. So what do each of these parts mean? Volume just means that we are creating a volume shader. Internal is the name that we created for this. It could really be anything. Think of it like a function name in other languages. And then these are the parameters that will be passed to our shader. And we can take a look at what does that look like by adding a script. In the drop-down box of the script, we will select internal.osl. And you can see what this does. So it creates a few inputs: radius, seed, f amount, and input color. Radius, seed, and amount are floating point numbers, while input color is a color. And each one of these, it's very important, each one of these has a default value. For output, we are outputting a closure color. The simple way to explain what a closure is it's essentially a function that describes how the color should be calculated. It's not itself a color like our input color, but instead a way of determining a color. So with all of this, we could theoretically connect this together, but it's not very interesting because as an output, all we are really creating is an output of absorption. So if we want to, we could render this. And the result would simply be a sphere that absorbs light. So next step, we are going to add a float f noise equals noise u Perlin, comma p, comma seed. This is a function, noise is a function that like its name suggests, creates noise. There are a number of different options. You can check out the Open Shading Language specification to see the different options. We have selected the unsigned Perlin, which returns a number between 0 and 1. To generate the noise, we use capital P, which is a defined variable in Open Shading Language that gives the position, and then our seed input, which we can use to change the noise, to find a noise that we really like. We are also going to create a variable called current distance, and that's equal to length of P. So P is the point that we are evaluating within the sphere. If we treat that like a vector, and we want to know essentially what is the distance between the origin and that point, and we're going to use that to make different areas within the sphere behave in different ways. So now we are going to say if f noise is less than 0.5, and if the current distance is less than the radius, then the point will be shaded using an internal algorithm that is specified by Blender and by the Open Shading Language as Henje-Greenstein. Otherwise, we are not going to do anything with that point. It will essentially be a transparent point. So if the generated noise is less than 0.5, and if the current distance is less than whatever we set as the radius, then the result is the Henje-Greenstein. Otherwise, the result is 0. Now, if the noise is between 0.5 but less than 0.6, then instead we are going to calculate the point as absorption times whatever we specify in the F amount. And that basically controls the amount of absorption. And finally, if the noise is 0.6 or greater, then we are going to create an emitter. and we are going to multiply that emitter times the input color, strengthen it by multiplying it 2 times F noise, which we already know that F noise is at least 0.6 and potentially as great as 1. And based on this, let's run the script node update. And we can see up here that OSL shader compilation succeeded. That means everything compiled as we expected it to. And then if we click to rendered, we see what it looks like. So you can see here, the bright white parts are places where we have our emitter. Some of these darker parts are places where we have some absorption, and then some of these blank spots where it's simply showing through. And perhaps if we really wanted to see what's happening in the background, we could add an environmental texture. And I've came across some really great HDRI images. We could put those in the background. And what this helps you to do is to see areas where it's either transparent, so the background fully shows through, or areas where maybe it's not completely transparent. You see a little bit of absorption. I will put a link to where you can find great HDR images like this in the notes below. All right, so great. We have this really great look. We could also add, now that we have the internal, we could add a glass shader and put the glass shader on top so it looks more like a marble. All right. So next, it's not very interesting with just white. And of course, I could change this, say if we wanted a green. But what I'd really like is for a color that rotates with time. And so what I'm going to do is I'm going to create another shader. And this one I am going to call shader color change. It will have a float F input seed equals 0 and a float saturation equals 1 and a float value equals 1. And an output color out color equals 1. And again, I'm going to go ahead and create a script, put it here. Oh, let's change the name of this to colorchange.osl. Select that. Everything compiles correctly. And now we can take the output color and put it into input color. Again, because our default value is 1, it means that we go back to just a white emitter. So let's do the next step. When I initially started this, I was working with RGB values and trying to use a complicated sine, cosine formulas in order to vary the color over time. However, I realized that there was an easier way to create this if I just used the hue, saturation, value color space. So to do that, what I want to do is I'm going to create a float called hue, and I'm going to make that equal to the input seed divided by 250. And in this case, I'm using 250 because I want to go through the entire color space over 250 frames. And I'm going to create the out color as equal to color, which is a function in open shading language. Specify for the first parameter that we want the HSV, hue, saturation, value, color space. Obviously, the second parameter is hue, third is saturation, and final is value. And hue, all three of these really work between 0 and 1. You can go beyond 1, but we'll focus on between 0 and 1 for each of these float values. Click the script node update, and as you can see, we have OSL script compilation failed. We can see the console for error. So we toggle the system console, and you can see error in line 3. So input seed was not declared in this scope. So looking at this, in our definition we used F input seed. Change that to F input seed and compile. We compiled successfully. So now with an input seed of 0, you get red. If we change this to approximately a third of 250, so let's do somewhere around 90, then you get more of a green color. And then if we do, let's say 180, more of a purple. So now, looks nice, great color. How are we going to drive this over time? Initially, I tried to create a driver on this value, and for some reason, that did not work very well. So instead, what I realized would work just as well as a driver would be to keyframe this. So if I set this to 0, if I start this at 0, insert a keyframe, and then I go to frame number 250, set the input to 250, can insert a keyframe now, and the CPU will not be able to keep up with this, but we'll show it just to show how the keyframe works. You show that as we go through the frames, this is also changing. And if we click to any particular frame, we'll see how it adjusts the color. That means over the space of 250 frames, which is slightly longer than 10 seconds, we will go through all of the colors, and of course, having the saturation and value parameters means that we can adjust these however we like. One thing that I might change, so here we've desaturated the color a little bit. One thing that I might recommend is if you go to the graph editor and you look at the graph for this particular, for the keyframes on this, and I'm going to normalize these. just so it's a little easier to see. You see that it starts off slow, goes quickly through the center, and then slows as it comes to the end. If instead we want it to be even the whole way, then we would click on the key, look at interpolation mode, and change it to linear. And this means it will change colors at the same rate throughout the entire, all of the frames. And that's everything you need to do in order to set up this particular open shading language script in Blender. I will put the details of how to do this, as well as a copy of the code that we used in today's tutorial on our blog at harlepenguin.com. Please let us know if you have any questions, and thank you for watching.